To analyze the model values for fixed assets, we need to first download the detailed information of PP&E from SCC Agger. I'm going to switch window to SCC Agger so I can show you where to find that information. So you will go to Agger and then pull out Caterpillar's 10K. And under Notes to Financial Statements, you will select Property, Plant, and Equipment. And once you click into that, you'll pull out the detailed information for PP&E. And this information has the useful life for each type of PP&E and what is the book values for each type of PP&E. And you can download this information into Excel by clicking on the View Excel Document button. And once you pull out this information on your Excel file, and your information should match with the sections of my Excel spreadsheet here. Since each 10K only includes 3 historical years information, so in order to come up at least 5 years of historical information, you need to combine the information from 2 different 10Ks. So this section, what's most relevant is the estimated book value for each type of PP&E in each of the fiscal year, and also the lifetime for PP&E. So if you don't see a lifetime listed for PP&E, that means this type of PP&E is non-depreciable. For example, land and construction in process, that means the buildings that you haven't completed building, they're considered non-depreciable assets. And if they're non-depreciable, we're not going to calculate depreciation expense based on those type of assets. The depreciation expense are only going to compute it based on depreciable assets. In this case, it will be building and land improvements, machinery equipments, and equipment leased to others. So based on the lifespan of each type of asset, then you can compute what is the estimated depreciation rates. And we're going to go through this later. Okay, so there are 2 different types of PP&E. There's gross PP&E and the net PP&E. The gross PP&E is simply summing up all the book values for each type of PP&E, and that gives you what is the gross PP&E. If you use gross PP&E and subtract out the accumulated depreciation, then you get net PP&E. So the next decision we have to make is which is the model value we're going to use. Are we going to use gross PP&E or net PP&E? And because PP&E is a relational variable, it's going the estimate for PP&E is going to be tied to sales, and therefore we have to estimate what is the net PP&E and gross PP&E as a percentage of sales. Sales can be obtained from the adjusted income statement. So if you compute what is the ratio for net PP&E as percentage of sales and gross PP&E as percentage of sales, the next goal is to see which measure of PP&E is more stable. So by doing this, you can just simply plot a line chart for these 2 types of PP&E. And based on this line chart, we see the year 3 or 2009 seems to be a lot outlier as comparing to the rest of the 4 years. And then comparing these 2 different measures, the net PP&E appears to be more stable than the gross PP&E. And in order to make more robust, accurate assumption for PP&E, we have to use the more reliable measure. In this case, we'll go with net PP&E as a percentage of sales. Okay, so that's why our model value for PP&E is set to net PP&E as percentage of sales. And to compute the model value for this assumption, I excluded the outlier in the middle for 2009 and then take historical average based on the net PP&E as a percentage of the sales in the rest of the 4 years. And then the assumption is 25%. Next, I need to estimate the model value for depreciation rates. Depreciation rate will be used to compute the projected annual depreciation expense based on the total amount of depreciable assets in the DCF model. To compute depreciation rate, you first have to calculate what is the sum of all depreciable assets. So in this case, there are 3 different types of depreciable assets. And then the sum of all depreciable assets will just be the sum of the book value for these 3 types of depreciable assets. And then I will compute what is the percentage weight for each type of depreciable asset in the total sum of depreciable assets. So for buildings and land improvements, I will use the book value for buildings and land improvements as a percentage of the total depreciable assets to calculate what is the weight for buildings and land improvements. And for the second type of depreciable assets, the machinery, equipment, and others, similarly, I use the book value of this type of asset as a percentage of the total depreciable asset to compute what is the weight for this type of asset. And similarly, for the third type of asset, is a matter of using the book value for this type of asset as a percentage for the total depreciable value for all depreciable assets. And if you do this for the first year, then you can just copy over this formula to complete what is the depreciation weight for each type of asset for each of the remainder years. Okay, and the next goal is to compute what is the average depreciation rate for each of the depreciable assets. And then this depreciation rate is calculated as 1 divided by the average lifespan of each type of asset. For example, the building and land improvement category, the lifespan is estimated to be between 20 years and 45 years, and therefore, on average, a typical asset in this building and land improvement category will have an average lifespan of 20 plus 45 divided by 2, which is 32.5 years. So that means this type of asset has an average lifespan of 32.5 years. And for the second category of asset, the lifespan is between 3 to 10 years. And therefore, on average, a typical asset in this category has a lifespan of 6.5 years. And similarly, for the third type of depreciable asset, the average lifespan is 5.5 years. Once you compute what is the average lifespan for each type of depreciable asset, then the depreciation rates, which measures how fast you are going to depreciate each type of depreciable asset, is simply 1 divided by the average lifespan of each type of depreciable assets. Okay, so once you've done that, then you are going to compute what is the average depreciation rate using the weighted average of depreciable rate multiplied by the depreciation rate weight for each type of depreciable assets by using a sum product. So if you're using sum product, you're using the depreciable rates multiplied by the weight for each type of asset. And because the weight of asset varies on a year-to-year basis, so you have to remember to log the rows and columns for depreciable rates, and don't log the columns and rows for the percentage rates for each type of depreciable assets. And then you copy over this formula to compute what is the average depreciation rates for the remainder of the years. And then you will observe how stable is this depreciation rate on a year-to-year basis. And since in this case, the average depreciation rate is fairly stable, and therefore I'm comfortable to estimate a model value for depreciation rate using a historical average based on the computed average depreciation rate for each year.